Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on how to find the empirical formula of a compound. So the empirical formula rules can be summed up here. We turn the percent to mass, mass to moles, divide by small, multiply till whole. So if you're given percentage, you just turn that percent sign into a gram sign. To convert mass to moles, we divide by the molar mass of the element. We divide by the smallest number of moles to get whole number ratios. And then if we still don't have whole numbers, then we can multiply by something else to give us a whole number. Okay, so let's get started. Our first question here is a compound contains 74.8% carbon and 25.2% hydrogen. What is the empirical formula? All right, so we always start off by what elements do we have in this compound? So here we have carbon and we have hydrogen. So the carbon that we have is 74.8% and the hydrogen is 25.2%. All right, so we're starting with percentages. So I'm first going to turn percent to mass. So we're just going to say we have 74.8 grams and 25.2 grams here. We can do this because when we switch from percentage to grams, we're not changing the ratio. The percentage stays the same. So what we're trying to do here is we're trying to find the percentage of mole ratio of carbon to hydrogen. So we do that by first looking at the gram ratio and then turning that into moles. So now we're going to go mass to moles. So I'm going to divide by the molar mass of carbon. Carbon is 12.01 grams. And then hydrogen is 1.01 grams. So when we do this, this is just en route to our answer. Our final answer isn't going to have any significant figures because it's going to be all whole numbers. So until we get to that point, we want to use as many decimal places as we can. So we use generally at least 3 significant figures behind the decimal. So that's usually 3 digits behind the decimal. And the more significant figures we use, the more accurate our answer will be. All right, so when we do this math, 74.8 divided by 12.01, we get 6.228 moles of carbon. And then when we do the bottom math, we get 24.950 moles of hydrogen. All right, so I've done percent to mass, mass to moles. Now I'm going to divide by the smallest number to get me to hopefully all whole numbers. All right, so I'm going to divide both of these by 6.228 because that is smaller than 24.950. All right, so when I do this, I get 1 carbon, and then when I divide the bottom, I get 4 hydrogens. So now I have whole numbers, which means that I'm done. The multiply till whole step is only if I don't get whole numbers. So here, since I've gotten whole numbers, I can just write my formula. I have 1 carbon and 4 hydrogens, so my formula here is going to be CH4. I don't have to put the 1 when I write the formula because the 1 is understood to be there. If you do write the 1, it's not incorrect, it's just not wholly correct. All right, let's do a couple more. So here we have a compound with potassium, chromium, and oxygen, and we're given the percentages. So we start by looking at our elements. We have K for potassium, Cr for chromium, and O for oxygen. So my potassium, I have 26.6%. The chromium, I have 35.3%. And the oxygen, I have 38.1%. So my first step is going to be to turn percent to mass. When you're doing these, you can skip this step and you can just go straight to mass. So you can start with 26.6 grams of K, 35.3 grams of Cr, and 38.1 grams of oxygen. That's totally fine. All right, so now we're going to go mass to moles. So the molar mass of potassium is 39.1 grams. The molar mass of chromium is 52 grams. And the molar mass of oxygen is 16 grams. All right, so now we're going to do this math. We're going to round to at least 3 decimal places. So we have 6.80 moles of K, 0.679 moles of Cr, and 2.381 moles of oxygen. So now I'm going to divide by small. So the smallest value here is 0.679. So I'm going to do 0.679, 0.679, 0.679. All right, so this is 1.000 something, which just rounds to 1. This is exactly 1. And then this rounds to 3.5 oxygens. If I get a value that's 3.5, that's not close enough to a whole number for me to go ahead and round that to 4. The only time you can round is if you're within one decimal place. So like 3.9, 4.1, or 4.01, something like that, that we can round. This we cannot. So here we've divided by small, but we still don't have all whole numbers. So now we multiply till whole. So if we look at this 3.5, 0.5 is just 1/2 as a fraction. So if we multiply this by 2, we can turn that into a whole number. So we have to multiply all of them by the whole number in order to keep the ratio constant. So in math, we learn that as long as you do the same things to all parts of the ratio stays the same. 1 times 2 is 2 potassium, 1 times 2 is 2 chromium, and 3.5 times 2 is 7 oxygen. So my formula here is going to be K2Cr2O7. Once you get to the point where you have all of the whole numbers, you still need to make sure that you come back and you write it as a formula, since we are looking for a formula. These values don't mean anything by themselves. We have to put it in the formula form in order for it to be correct. Next up, here we have glycerol is an organic compound used as a sweetener and preservative. Determine the empirical formula. So this compound contains carbon, hydrogen, and oxygen. So I start off with my elements. I have C, H, and O. All right, so according to my problem, I have 39.12% carbon, 8.77% hydrogen, and 52.11% oxygen. All right, so now I'm going to do percent to mass. Now that I have mass, I'm going to divide by molar mass. I have 1 mole, carbon's molar mass is 12.01, hydrogen's molar mass is 1.01, oxygen's molar mass is 16. So now I'm going to put this into my calculator. I get 3.257 moles carbon, 8.683 moles hydrogen, and 3.257 moles of oxygen. 2 of these are the same, which is great because that means I have less math to do, and that's the smaller one. So I'm going to divide everything by 3.257. When I do this, I get 1 carbon, I get 2.67 hydrogen, and I get 1 oxygen. All right, so here again, I do not have all whole numbers. I have this 0.67 decimal. 0.67 is 2/3, so I can multiply all of this by 3 to get a whole number. So 3 times 1 is 3 carbon, 2.67 times 3 is 8 hydrogen, and 1 times 3 is 3 oxygen. So I get C3H8O3. Excellent. All right, let's continue on. Okay, next up, we're asked to find the empirical formula of a compound that contains carbon, hydrogen, and oxygen, and we're given the percentages of carbon and hydrogen. This is where it's important to read the problem. We don't have just carbon and hydrogen, we also have oxygen. It just doesn't give us the percentage. So we have to calculate that percentage before we can do the empirical formula. So all of our percent compositions have to add up to 100. If carbon is 35.546% and hydrogen is 5.22%, if I subtract both of those from 100, everything that's left has to be oxygen because it's the only other thing that's in my compound. So when I do this, I get 59.32% oxygen. So now that I have my percent oxygen, I can continue on with my problem. So I have carbon, I have hydrogen, and oxygen. Carbon, I have 35.46%. Hydrogen, I have 5.22%. And the oxygen, I calculated to be 59.32%. So we'll do percent to mass. Now that we have mass, we can do mass to moles. So I'm going to divide by the molar mass. So I have 1 mole of carbon is 12.01 grams. 1 mole of hydrogen is 1.01 grams. and 1 mole of oxygen is 16 grams. Right, so when we do this, we get 2.952 moles of carbon, 5.168 moles of hydrogen, and 3.708 moles of oxygen. All right, now we divide by small. So the smallest value here is 2.952. So I will divide all of these by 2.952. So I get 1 carbon, I get 1.75 hydrogen, and I get 1.25 oxygen. So I have 2 decimals here. 0.75 is 3/4 and 0.25 is 1/4. So I should just be able to multiply all of these by 4 and get all whole numbers. So this is going to give me 4 carbons, this is going to give me 7 hydrogens, and this is going to give me 5 oxygens. So my formula here is C4H7O5. All right, let's do a couple more. Here we're finding the formula of a compound that has vanadium and sulfur. Vanadium is V, sulfur is S. I have 51.4% vanadium, 48.6% sulfur. Do percent to mass. Now I do mass to moles. Molar mass of vanadium is 50.94 grams. Molar mass of sulfur, 32.06 grams. When we do this, I get 1.009 moles of V and 1.516 moles of S. So I divide by the smaller one, which is 1.009, 1.009, and I get 1V and 1.5 S. So 0.5 means that I multiply by 2, so I get 2 V's, 2 times 1.5 is 3, so I get 3 S's. So I get V2S3. Excellent. All right, let's do one more. Here we have a compound with sodium, sulfur, and oxygen, and we are given the percentages of sodium and sulfur, but we don't have the percent of oxygen. So here we have to do the same thing that we did previously. We have to figure out how much oxygen is in my compound. So I have a total of 100%. So 100 minus 29.08 minus 40.56, and that's going to give me 30.36% oxygen. All right, so now I know the sodium, I know the sulfur, and I know the oxygen. Those are all my percents. Those are all my masses. Now I divide by molar mass. Sodium is 22.99, sulfur is 32.06, oxygen is 16. So when we do this, I get 1.265 moles of Na, 1.265 moles of S, and I get 1.898 moles of oxygen. Right, so the smallest one here is 1.265. So I divide all of them by 1.265. I get 1 Na, I get 1 S, and I get 1.5 O's. Right, so again, I have a decimal. So if I have a 0.5, I multiply by 2, and I get 2 Na, 2 S, and I get 3 O. So this is Na2, S2, O3. Excellent. So that is how we find empirical formula. This has been another episode of Chemistry with Wikipedia, Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.